So sometimes I can annoy my wife. This is because I spend a ton of time in my office, whether I'm working from home or playing video games, which is a huge hobby of mine, or filming videos like this. When I get into the zone, I seem to cut out the outside world. I usually have noise canceling headphones on, and I'm not really checking my phone that often. And this could be a problem when my wife needs to get a hold of me, whether it's to help her get groceries out of the car, help her with our baby. Sometimes they're more urgent than others. Sometimes the baby needs attention immediately. One time it crapped all over our room. She really needed to get my attention. I was playing video games. These types of situations can't happen. We're gonna use a little bit of software engineering, some 3D printing. We're gonna come up with a device that I'm gonna call HusbandAlert. I took a second to throw a few of the details up here on my blackboard beside me. Typically, I do mostly 3D printing videos. I am a software engineer by trade, so this is going to combine a little bit of software, hardware, and 3D printing, so this should be a fun one. I did a terrible job at sketching what I think this is going to look like, but really I was thinking a box that's going to sit on my desk. It's going to have a ring of LEDs on the top, which should visually get my attention if my wife needs me. And it's going to have a momentary switch or a button right in the middle of those LEDs so that I can acknowledge my wife's request for my attention. And I can also snooze just in case I'm in a meeting or something. I can alert her that I've seen your request and I am busy at the moment. First thing I'm going to look at is writing the LED driver. Here is the LED ring that I bought. Pretty sweet. So it's like a day or two later, I finally got some time to write a somewhat hacked together LED driver, so let me show you what I got. Well, I wrote a decent amount of code here. I wanted to build an LED driver along with a small hacked together animation engine, so I wrote all this code, but this is the interesting stuff. So all that code allows me to do is have these simple lines to build out some animations. So I have a sample startup, alert, emergency, and snooze animation. And it's only like 5 or 6 lines of code for each animation, but the engine and the animation engine itself is a little bit bigger. Here we are again, another night, another successful piece of code written. Let me show you what I got. I got my button wired up to the Raspberry Pi. I can do a press, as you can see, short button press, and then a long button press is a 1.5 seconds, 1 Mississippi, 2, and I come up here, long button press. Okay, so the LED driver's done, the button driver's done. Now it's time to work on the main device logic. First, I want to take a look at one example of an input on the system and show you how you might code it. But then I want to talk about a concept called state machines, which is very common in software engineering, but it's a great way to visualize the device behavior and make a very robust software solution. I wrote out some pseudocode if we receive an emergency event. This is the type of event that the device will get when my wife's trying to get my attention immediately. And this is how somebody might implement this. When you first receive the emergency notification, you're going to check your state because you want to see if you're in the busy state or the alert state, because we have an animation playing when we're in those states. So if we're in one of those states, we have to stop that animation first. And then after you stop the animation, you have to go and check, is the state idle, or is it busy, or is it alert? Because those are the states in which we are allowed to transition to the emergency state. So if we're allowed to transition, then we can play the animation for an emergency, we can notify the website client, and we could set our own state. Oh, should only be 1 equals there. We're setting our state equal to emergency. Now this is just a very small part of the code that only handles the emergency event. Well, we have the alert state, we have an emergency event, we have the ability to acknowledge both an emergency and an alert. We have the ability to tell my wife that I'm busy by setting ourselves into a busy state. We have a startup state and an idle state. And there's all these events that you're gonna have to check in each one of these handlers. Are we in this state? Do this. Are we in this state? Do this. And all that code spread throughout the code base, and it can get very confusing and things start to slip through the cracks. So I took a little bit, I thought about the device and how it's going to be used, and I thought about what states can the device be in and what events cause that state to change and move to a different state. And this is what I ended up with. Here's an example flow using this state machine to show how the software is going to work. So on startup, we're going to be on the startup state. This is our beginning state. And then we're going to initialize our LEDs, our button, our web server. We're going to get all that up, and then we're going to send an initialization event, which is going to transition us into the idle state. The device has no LEDs on, it's just hanging out, waiting for something to happen. And then say there is an alert. My wife presses the alert button on her phone, it gets received on the device. So all that handler does that receives that event just tells the state machine, hey, an alert has happened, do whatever the state machine is supposed to do. So the state machine says to itself, okay, I'm in the idle state, I got an alert event, so that means that I should transition from idle to the alert state. Now the state machine engine, it depends on whatever you're working on. There's a Python open source library that I'm going to use for this, and it allows you to perform certain actions on exit and enter of the state. So in this example, when I'm exiting idle, I don't really need to do anything, but when I enter the alert state, I need to play the LEDs, I need to notify the web server that our state has changed, so that way the UI on the phone can change. Now, say some time passes by, and my wife wants to bump that to an emergency. She can send an emergency event now. So the state machine will receive that event, and it will check, okay, it'll stop playing the alert animation, it will transition to the emergency state, it'll play that animation, and it'll send through the web server, this is now our state. And same thing goes if I want to acknowledge that emergency, I can press the button, a short press. When I receive that short press, all I do is tell the state machine it's a short press. And it'll say, okay, it'll leave the emergency state, stop that animation, go to the acknowledgement state, and so on. So you really want to take some time, draw it out, and think in your head, how's this device going to be used, and make sure you have all your state transitions done, and then the rest is easy. I pulled out a late night coding session and I got all the functionality implemented for the device. Let me show you what we got here. Here's the first official test of the HusbandAlert on the actual hardware. So I'm going to start up the device. And while it's initializing all the WebSocket servers and the button drivers and stuff, it's going to play an animation on the LEDs showing that the device is starting. So now we're just sitting in our normal idle mode. If I open the web page associated with the device, it says that I'm available. Now, if I have a meeting or I'm filming or doing something, I can hold this for 2 seconds. And it puts us in the busy state. And as you can see on the app, it notifies the user that the husband is busy at the moment. So let's turn that off. The meeting is over. Now, if my wife wants to get my attention, she can hit the alert button, which will notify me via the LEDs that she needs my attention, and I can press the button, and she can see that I saw the alert and I will be with her shortly. Same thing goes for the emergency. So that's it. I just have to make the code start on startup of the Raspberry Pi, and we are done with the software. I did not film any of the drawing, but this is going to be the enclosure for the device. So it's got a top shell and a bottom shell, and then it's got a white ring that's going to drop over the LEDs. So if I get rid of the top and the ring, the Raspberry Pi will sit on these standoffs. I have a hole in the back for the USB cord. And then the LEDs are going to sit in the top section here. And there's a little cutout right here to allow the wires for the LED to come through. There's obviously a hole in the middle to put the button in. I printed out the 2 main pieces of the enclosure. The top looks great. There's the button and the LEDs sit nice and flush. The first LED that lights up in the startup animation lines up perfectly with the dead center of the back of it. So let's get this other piece printed out that's going to push into the top here and hold the LEDs down, and then we'll try and get the rest assembled. Alright, there we go. We got the top of the unit installed here. I thought I was going to have to use hot glue, but the actual tolerance of this ring seated into the top of the lid is keeping the LEDs perfectly in position, so all good there. I'm not sure why I made the standoff so high for the Raspberry Pi, but the problem is the button is hitting the Pi when I put the lid on. So, unfortunate. I'm going to try and shift the Pi back a little more and lower it significantly to see if I could get everything to fit in there properly. Oh, there we go. Wow, this thing looks incredible. Look at this thing. It looks fantastic. I am incredibly impressed with how this turned out. I mean, it looks like something that you would buy at a store. The print is super nice quality. It fits together perfectly. It's nice and small. Kind of looks like an Echo Dot or something of a similar footprint. And we're about to plug it in for the first time and see it light up. So let's do it. So we have the app up. It says that husband is available currently. And I can hit the alert button. And as you can see, we're getting a pulsing yellow light to signal an alert. It can also be upgraded to an emergency. And it's kind of like a police light. And the status currently is emergency alert being displayed to husband. I better tell her that I saw it. So I press the button once and it does a pulsing blue. And on the app, it says that husband saw the alert and will respond. Oh. Yes, dear.
Can you get me some water?
Sure. Do you think it was worth all the work?
Uh-huh.
Alrighty.